Okay, Geoff, we've got 35 people now. Please tell us about yourself. Well, and then we'll
Okay.
start properly in 5 minutes.
Okay, so thank you for inviting me. I'm Geoff Rayner-Canham, a longtime member of the Royal Society of Chemistry and its predecessors. I'm at Memorial University in Newfoundland, and it's the Grenfell campus, which is on the west coast of the island of Newfoundland. So it's very different to the east coast, where the capital, the west coast, is more like Norway, continuation of the Appalachians. And just to start off, this presentation and the work would not have been possible without my two Inuit student associates, researchers. So first of all, Chaim Christiana Anderson, and the second one is Rosalina Nakitavik. So they provided the Inuit content and many of the ideas that you'll learn about today. So who are the Inuit? And first of all, just to mention, never use the E word. The E word was a derogatory term devised by the southern indigenous people as an insult against the Inuit. So never use the E word. And here's some Inuit women and their child in their traditional outfit. This is a outfit worn by women who've got young children with a separate hood for the baby to be in. So they came across in a separate wave of immigration across from Siberia, and so they're totally different in culture, in genes from the southern indigenous people, and they spread across in a series of waves. And you can see there the sort of directions they went. And so they're not homogeneous in terms of language, but we won't get into that. That was an interesting thing that I learned as we went along. So these are the Inuit homelands in Canada. So down on the right-hand side, you have on the Nunatsiavut. This is the self-governing northern part of the province of Newfoundland and Labrador. Nunavik, which is the northern self-governing part of Quebec. Nunavut, which is a separate territory all by itself with its own capital. And Inuvialut. And that's a little bit weird because it's the northern parts of Northwest Territories and the Yukon. And there's also a part in Labrador called Nunatukavut, which is claimed by the Inuit, but is contested by the current provincial government. And a lot of people, including many Canadians, do not realize that the Inuit lands actually comprise 35% of the land area of Canada and 50% of the sea frontage. So it's a huge part. And you might look at the black dots of the settlements, and you notice, with one exception, that they're all on the sea, because the Inuit life and culture and food sources are mainly around the sea. Now, how did I get into this? Because you must be wondering what took me into this area. That from 2002 to 2018, I did outreach to remote communities in Newfoundland and Labrador, including up to Nunatsiavut. And what struck me was that apart from all of the schools, the Inuit schools up in Nunatsiavut were absolutely the kids were absolutely fascinated by chemistry, absolutely enthralled by it. So I got a grant to go across Nunavut, and in anticipation that maybe this applied to Inuit students across there. And I was not disappointed. This is a picture taken in Johaven in the northwest part of Nunavut. And you can see the children, even the little tiny ones, are absolutely enthralled by the chemistry demonstrations. And incidentally, one of the students in there is in my chemistry class this spring. And I continued doing it. And I was very fortunate in the later years to acquire an Inuit student in my beginning chemistry class at university, and she joined the team. And there you can see her in the multicolored lab coat. That's Chaim there. And that was in 2017. And this work was supported by the Chemical Education Fund of the Chemical Institute of Canada, and also by the National Science and Engineering Research Council of Canada through their Promo Science program. Now, in at the university that I co-teach a course called Chemistry in Everyday Life, and it's a very popular one which goes over all sorts of aspects of chemistry. But the university announced that it wanted to indigenize courses, and this is particularly important for the Grenfell campus because 30% of our students have indigenous heritage. And myself and my co-instructor started working on this, and by absolute coincidence, total coincidence, that in January 2022, that we got an email stating that Nunavut Arctic College needed a science course for their education students. And this is Nunavut Arctic College is the sole college for the whole of Nunavut, all across the northern part of Canada. And it serves the largest post-secondary service region in Canada. It's one of the largest by area in the whole world. As you can imagine, having just seen where Nunavut is, it stretches right across 3 different time zones. And so we rapidly incorporated the indigenous content into the course. And that was where I got to see Rosalina, because she was the most enthusiastic student in the class at that time. But also, every week the students had to do discussion posts, and they related it to their own lives and learned a lot from them, as you'll see too later on. So let's start getting into the content rather than just the background. So hydrogen bonding in water is so important. If it hadn't been for that, there would be no Inuit peoples and culture. So first of all, the igloo, you're all familiar with an igloo, I think, but what's often overlooked is how the passageway to get into one is sunken. By this means the warmer, less dense air is trapped inside. And also you can actually do calculations, I can't, knowing the thermal conductivity of hard-packed snow, the thickness of the walls, you can actually work out the temperature differential that you can maintain in there. It's typically about 20 to plus 20, even when it's about minus 15 outside. Now, it's quite a while since this was the main form of living for Inuit, but they still make them. And this is one just a few years ago, and they're called kagik if they're very large. And some of them are absolutely enormous. They're meeting places. And what it doesn't show is that inside it's translucent. So you actually get a sense of, you're not just darkness, it's actually light inside there. But they keep alive the culture. But equally important is it's still realized that it's a good insulator. So the houses are insulated, and Shane talked about how growing up that they had a race to see who could cover their parents' houses in packed snow the fastest. And this picture was taken in 1910 on Okak Island, which is where Shane's family historically came from. And so this was probably one of Shane's great ancestors. Now, one of the other things that is important for is that snow and ice particularly, is the means of getting out to get food in the winter. And here's Shane with a 202 going out hunting for seal. And the other thing is the spectacular nature of the scenery. It is absolutely amazing. And here's Rosalina fishing for Arctic char. This is in spring, clearly, from her clothing and from the background. And the other thing is that the communities are totally cut up from one another. There's no roads, nothing. But in winter, of course, because it's all ice and snow, they can travel on snowmobile. And this is Shane and the daughter traveling to the Okak Islands, where, as I mentioned, her family came from. So the snow and the ice makes travel between communities feasible, which are not feasible otherwise. So hydrogen bonding in water is absolutely essential to every aspect of the Inuit way of life. Atmospheric chemistry, and this brings us to aurora and the atmospheric structure. So the aurora is in the thermosphere and the upper mesosphere. And you see it, and here's a picture taken from Rosalina's home community, Arctic Bay. And you can see it's pretty. To us, it's pretty, but to Inuit, it helps lift their winter depression, because for 2 months the sun never rises. It's black all day, all night. So when the auroras start up, it's absolutely innovating. It brings them to the Inuit to life. It's something to really bring joy to the community, to have the sky lit up like that, and there's so many ways with the different colors. And it's embedded in the Inuit culture. And here's a book, Inuit Children's Stories about the Aurora. Now, distillation, we chemists know all about distillation. And here's a typical fractional distillation column. But it's also important on the global scale, because volatile organic molecules and also elemental mercury volatilize from the warmer climates and are carried up, and they condense in the cold polar regions. And this is chemically called global distillation, but is also more colloquially called the grasshopper effect. And so very high levels of mercury in the Arctic and in the food chain and into Inuit people themselves. And also this family, the perfluorooctane sulfonic acids and their relatives and derivatives, which are used widely in the production of plastics and which are still being produced in the and leaked into the atmosphere in the United States, particularly where they get up into the Inuit. And here's a diagram which shows the levels of PFOS and its relatives in seals, which are the mainstay of the diet across the Inuit homelands. You can see it's staggering concentrations, absolutely staggering. Now, metals are very important, and this is Rosalina with an ulu. The ulu is the woman's knife for cutting up food, and it makes sense because you press down on the blade, and when you think about a typical Western knife, you're holding it at right angles to the direction you're trying to apply pressure. And in fact, if you go on Amazon, you can actually buy ulus that are with all sorts of things like titanium, carbon, steel, and Kevlar handles, all sorts of fancy things. But in Inuit culture, they're highly valued. And this is one in Chaim's family, and it definitely dates back to at least her great-great-grandmother, and probably a lot longer. So this is a highly valued item. But the question comes, what about the blades? And traditionally, going back tens of thousands of years, they were made of slate, because as you know, slate cleaves into nice thin layers, and then you can just put an edge on it. And this is 200 to 300 years old, probably. There are also copper-bladed ones. And in the northwest of Nunavut, there's actually copper metal deposits on the open ground. So, and again, this is at least a couple of 100 years old. And so this is a blade fashioned beaten from the copper found on the ground and turned into an ulu. This is made with iron. Now, this might surprise people because iron's not naturally found as an element. So where does this come from? It actually comes from a meteorite that landed in Greenland. They're still not quite sure how many tens of thousands of years ago it landed. It was an iron nickel meteorite, and it had a specific composition, unique composition, because it contained crystals of chromium-3 nitride. And these ulu have been found all across the eastern part of the Inuit lands, not just Greenland, but into the Hudson Bay area of Nunavut, Nunatsiavut, and even down further south. So chunks were cut off it, and this is one of the first thefts of Inuit culture, that Western explorers found this great big meteorite and transported it down to the Smithsonian, removing the source of iron. Organic chemistry is another aspect that relates to Inuit life and the diet. So one of the main items in the diet is seal, and this is the seal blubber, which is eaten raw, and you can see the saturated, monounsaturated, and polyunsaturated fatty acids. In fact, the traditional Inuit diet is incredibly healthy. All the sorts of things we should be eating. Well, not quite, and I'll get to that in a minute. Seal liver is eaten raw, and that's a source of vitamin A. But you might wonder how Inuit never suffered from scurvy from vitamin C deficiency when all around them, particularly the Western explorers, were all dying. And the answer is seal liver is also rich in vitamin C, provided you eat it raw. So this is the traditional source of vitamin C in the Inuit diet. Now, in addition, in the summer, the Inuit go overland to pick berries, and then they store them under seal oil, which is an effective way of preserving because seal oil has very low oxygen content. And also Canada geese eggs, and Rosalina reminiscent about when she was as young as 3 years old to go out and collect Canada geese eggs. But she always knew that you always left 2 eggs in every nest just to make sure that they'd be there again next year. And sometimes her family had to travel 12 hours to get to the nesting grounds. Oh, yes, it's a very different diet because, as you might have gathered, it's almost free of carbohydrates. But over generations and genetic changes, this is something that the Inuit have adapted to. So they live on a virtual traditionally carbohydrate-free diet. This has been a real problem in recent years, is that the corner stores and the supermarkets all carry all these wonderful things like potato chips, and it's a real problem for the in terms of weight gain and in terms of losing their traditional very healthy diet. And there's a move to try and get back to it. Arctic char is one of the main fishes. As you saw, Rosalina was catching one. And Arctic char have a very high metabolic rate. They need high oxygen contents in the water. And if you look at the map of the world, you can see that the oxygen concentration is much higher in these very cold climes. And this is a problem with warming waters because the Arctic char moving further north. Here is a typical Arctic char. So it's a relative of salmon, but it's a distinct species and very, very rich in all the good things, the omega-3s, the omega-6s, protein clearly, and it's dried and contains, in particular, eicosapentaenoic acid and all these other healthy things. Now, the curious thing is that it's eaten with soy sauce. Now, I've asked people in the Arctic, so how long has this been going on? And they say, oh, it's traditional. We've always had soy sauce. And I think, no, you haven't. But no one seems to go back far enough in order to say, oh, yes, it was brought here by so and so. But one of the advantages of dipping the dried Arctic char in soy sauce is it also adds niacin, vitamin B3 to the diet. But it's really curious. You speak to any Inuit and they say, oh, we've been using soy sauce forever. Well, I guess before you immigrated from Asia, you did, but I can't see taking a soy sauce factory across the Arctic. Inuit remedies. So this was interesting talking well, not talking, but online with the students from the Inuit class. That in the Arctic, you find dwarf willow, which is a tiny little plant. You all know what a willow tree looks like, but like the big tree, the dwarf willow contains salicylic acid or salicin, whoops. All the students knew the fact that if you got toothache, what you did was to go and in the summer look for a dwarf willow and chew on it, and it killed off the toothache. Because again, in these remote communities, you don't have a dentist there. You've got these days you fly into Iqaluit or one of the other Cambridge Bay, one of the other big centres to get dental treatment. So in the meantime, dwarf willow is the way to go. You didn't have a boots on every corner either. This was one that I learned from the students because I said, what about if you have bacterial infection. They said, oh, puffballs. And, you know, some people deride these indigenous remedies, saying, oh, yes, it's all folk medicine and shamans and stuff. No, it's not, because apart from the fact the student said, oh, it works definitely, that if you go to the National Library of Medicine, you can find a very comprehensive article, a research paper on the antimicrobial activity of puffball. Puffball is a fungus, sort of clearly related to a mushroom in terms of its fruiting spores. So these are two of many of the remedies which have been used by the Inuit, because, as I said already, that they're very isolated communities, and you have no pharmacy, you have no doctors, and in history, of course, there weren't such things anyway. Now, some inorganic chemistry now, and some minerals. So most of the Nunavut, Nunatsiavut, and Nunavik consist of very old rocks. In fact, some of the oldest on the planet. You can look at the radioactive isotopes and find out that they're as old as 3.8 billion years, or even older. Very, very hard, very resistant. But they have a use for the Inuit, and that's for making inuksuk. If you look at the central picture, you can see that, or you can imagine, if this is all covered in snow, you have no clue which is north, south, east, or west, how to get back to your community, how to travel to another community. So they use this very hard rock to build these towers, pyramids. Each one had a unique shape, so that you never got confused. They were each one very precise structure, and so you knew that one was near this village or wherever, or this was on the way to the fishing grounds. So, and there's no idea. It's very difficult to judge the age. There have been ways of doing it, and some of these date back hundreds, if not thousands, of years. Now they come in all shapes and all sizes. And here's one in the shape of a person, and it's called an Inorganic. And it's a common myth that all of the inuksuk are human shapes, but it's only certain ones. And it's not clear why some are. This goes back again into prehistory. And it's such an important part of the culture that the flag of Nunavut has an inuksuk or Inorganic on it, and as does the flag of Nunatsiavut. So this is another part of their culture. And it's all because these rocks are incredibly hard and survive for generations, for thousands of years, as landmarks that all the Inuit know where they are all across the north. There's, in addition to the very hard minerals, there's softer ones. And soapstone is very highly valued. And there's soapstone deposits across the north, and depending upon the trace elements, they come in different colors. You can actually identify which quarry they came from. So they're used to make these bowls, which are used for heating, for lighting, and for cooking. And one of the major components of soapstone is talc, and you can see why it's easily cleaved, because it has these layers of magnesium hydroxide. And so it really is, as it says, soapstone. It has a soapy feel to it, and it can be carved very readily. And one of the students in the class sent a picture of her great-great-grandmother with a kulik with it lit up. And if you're wondering what the wick is made of, it's made of the Arctic cotton grass. And this is an interesting little side story, that the Inuit once were much further south in the east, in Newfoundland and Labrador. And when I was waiting at the southern tip of Newfoundland to get the ferry over to Nova Scotia, went to visit this archaeological site where it's believed that Inuit lived hundreds of years ago. And what struck me was that just outside the building, there was a field which was full of Arctic cotton grass. And just to me, it was a no-brainer because the Arctic cotton grass is not native to Newfoundland. So why was there a field of Arctic cotton grass right down in the southwest? It had to have been an Inuit settlement. And they brought down the cotton grass to grow so that they could make wicks for their quillic. And these again are handed down. And it's also very ceremonially important. When the Nunavut was declared a territory, there was a ceremonial lighting one. And Rosalina said that she was privileged to light one at a school at the graduation ceremony, that this always started off the graduation was the lighting of the ceremonial quillic. Composite materials, well, it's so ironic because composite materials are now the in thing in chemistry research, these combinations of properties, and one that's been around for a long while, that's concrete and reinforced concrete and things. But the Inuit have always used composite materials, primarily in terms of clothing. And if you look at clothing, one of the major components is collagen, and it consists of amino acid chain and triple helix, and then fiber bundles. And this is one of the major components that provides the strength of skin, seal skin, caribou skin, and what can be used for clothing. And this picture is quite a coincidental one. I was in the capital Iqaluit back in 2009 in the high school there, and two students came in with their babies in the back of their Malti, and they're very colorful now. Traditionally, they were like the early ones because brown was the only dye stuff available, but now they take full advantage of the synthetic dyes that are chemically made to produce these wonderful, colorful costumes. And this is another piece of clothing. This is from seal gut because it's hydrophobic and it can be made into basically rainwear. Now, the key thing, and it's very apparent from the waterproof, that you need to be able to sew, well, from all of these. So one thing that's often overlooked in cultures is the importance of having needles. And this is in a museum, this is a traditional sewing kit. And here you can see the bone needles and the walrus tusk case that they're held in. And the sewing was done not just for clothing, but also to make the boat coverings. Now, you're all familiar with kayaks, I'm sure, and the word which comes with kayak is an Inuit word. The English language, you know, steals shamelessly from every other language around the planet. But in addition to the well-known kayak, and you can see a little kayak down to the side there, that to traveling and to summer fishing camps, they used umiaks, which are sewn together seal skins over either whalebone or wooden frame. And the one in the foreground has women in it because the women used oars like that, whereas the men, paddles like that, whereas the men used oars. Now, one of the things in terms of culture is that there are many dead cultures, and some that we try and revive. Like I know back when I grew up in England was the Morris dancers. I mean, we don't go Morris dancing every day, or didn't when I was growing up. It was something you hauled out for ceremonies. But the Inuit is very much a living culture, adapting and adopting. So one of the things that changed the Inuit life was the invention of what originally was meant to be called the ski dog. However, there was a misprint and it came as the ski doo, but the original name was supposed to be the ski dog. This is the very first one of 1962. But in order to work in the Arctic, you need chemistry because you have to have special oil for Arctic conditions. So this is what's made it possible to use snowmobiles in the Arctic as being the chemistry of the oil. And they're used very widespread. Here's an Inuit mom taking her children to school. And here's an Inuit children in a trailer called a komatik. And as an Inuit would tell you, there's advantages and disadvantage. Disadvantage is that if compared with the husky dogs, if you get lost in the middle of winter, you can always eat your husky dogs, you can't eat your snowmobile. On the other hand, you don't have to feed the snowmobile all summer long when it's sitting up on a bench, whereas with the dogs, you've got to keep feeding them all through the summer. The Ulu has changed because they're very frugal culture. And here's a circular saw blade, which is made of toughened steel. So you can see here that you can get actually 3 ulu out of it. And here's a completed ulu made from one of the 3 made from a discarded circular saw blade. Now, this is another curiosity that Nunatsiavut, among the first people, Western people to go there, or European people is a better term, were Moravian missionaries. Now, some of you around Lancashire would know about the Moravians because they were around Manchester, and there's actually a Moravian settlement and a historic site in Manchester. And they came over and settled, and not a very pleasant story, forcibly converted the Inuit to Christianity. But one thing they brought with them was rhubarb. And rhubarb has now become part of the diet. Here's Elder Annie Evans in the Nunatsiavut picking rhubarb. And rhubarb is rhubarb jam. Eating rhubarb dipped in sugar by the children has now become an established part of the culture, which I'm sure people say, well, we've always been doing that. The other thing that's curious is it seems to have a different genetic makeup. So whether it is in fact still the Moravian rhubarb, or whether some of the rhubarb was brought from Tibet or Mongolia, which is where it's native to, we'll never know. And rhubarb has vitamin K in it, very high levels of vitamin K. And so this is another added part to the diet. A big problem is snow blindness. And traditionally, there's some beautiful masks made from different bone. And even then, it's still possible, and even today, it's possible to get snow blindness, even wearing UV goggles and everything. But the Inuit found out that if you take orange oil from oranges, which are now found in corner stores up in the north, that actually it alleviated the pain of snow blindness, even though there's actually no current cure for snow blindness. And so I thought I'd do some research, and sure enough, that you can find research papers and patents stating that the terpene limonene, which is a component of orange oil, is actually efficacious against snow blindness. Now, the big problem, as I'm sure you've gathered, is climate change, because here I've been going on about the cold is so important to Inuit life, the freezing food during the winter, the going out and hunting on the ice. And if you look at this picture, it's very, very scary. The extent of the sea ice starting in 1850 and going on to 2012. And of course, it's even worse now. And I don't know whether you know, but it actually rained at the North Pole on Christmas Day. And you can see also the air temperatures difference from average October 2022 now. And I went up this June to Iqaluit, and I had all my usual winter gear, and I finished up hiking over the hills in shorts and t-shirt because it's just so warm. So this is a very good quote, I think. The Arctic is ruled by ice. For Inuit, it's a platform on which life is lived, but the ice is melting and becoming dangerous. Inuit are witnesses and messengers of climate change. The increase in temperature in the Arctic has been horrendous, like 5, even 10 degrees above normal, which is dramatic if you think of a culture that's used to temperatures between -20 and maybe +10, and you now look at +20 and even +25. It's devastating, particularly the lack of ice in winter to go hunting for seal, for Arctic char. So to conclude, all this, or most of this work has been published in a special issue of the Canadian high school magazine Chem 13 News. And here's Rosalina clutching a copy of it. And we've also put together, Rosalina and I, a presentation to take to Inuit schools, sort of looking at some of these aspects and bringing to light the links with chemistry in the hope that the Inuit students will continue with science courses and go into science-related careers. And that's me, and that's my email address. And this is the link, but don't worry, don't rush to copy it down. It's a 76-page issue, by the way, 76 pages of glorious color, of interest, of some of what I've talked about, plus others. But all you have to do is put into Google Chem 13 News Inuit, and it will bring you straight to the page of the special edition.
Thank you very much, Geoff. A very, very interesting talk, of course, about a facet of the world that most of us know nothing about. I've got a few questions for you. The first one is by me, and I hope you haven't mentioned this already. I don't think so. That is, has a chemistry textbook ever been translated into an Inuit language? Does the fact that Inuit exists in a number of variant dialects create a problem in translating books?
Yeah. As far as I know, and I'm a visitor to the north. As far as I know, they take chemistry in English, and I don't think there is an Inuit translation of a chemistry textbook. But he's quite right. It was Rosalina was so helpful, because right at the beginning of the course, she sent myself and my co-instructor a list of Inuit terms, and one of them was, don't forget your assignments and quizzes are due on Sunday in Inuktitut, the standard language around Iqaluit. And so I put this in the reminder to students, and we got back students from Western Nunavut saying, what's this? I don't understand a word of it. And I forgot Western Nunavut speak a totally different language. And Rosalina up in the far north, that she has words that other people don't understand. We think that's because the Thule people who preceded the Inuit culture had a different language altogether, and it survived up in the far north. But anyway, to answer the question, as far as I know, that English is the standard language in the Inuit schools above the beginning grades. And Nunavut Arctic College is all taught in English, apart from the language and culture courses.
Robert Flynn asked, I've heard of cadmium and lead in addition to mercury found in tuna. Are the former two metals, that is cadmium and lead, found in Newfoundland and Canada?
Wait a minute, I'm trying to open up the chat, okay. Okay, so this is the question. It sounds as though
I think he was just trying to draw a link between the fact that if cadmium and lead are found in tuna, that may, are there sources for these metals in Newfoundland?
No, there aren't. No. All of it comes up pretty much all comes up from the United States.
Right. That's now, Louis Claudio asked, is there a problem of contamination of breast milk in the Inuit population by DDT?
That's an excellent question, and it's a very bad problem. You can find research papers on the elevated levels of these in breast milk, and the problem is that milk has to be shipped up from the south, and it doesn't last very long up north, and so, which is good and bad. So breastfeeding is the main source, but it is very high. It is a serious problem up there, and there's no solution to it except fear among the Inuit peoples. I hope that answers.
And I had wondered if myself actually. It sounds as though much of the diet is eaten raw. So what do they cook in the kuluk? Hope I'm pronouncing that.
That's an excellent question. Yes, most of the fish is dried. They cook it, especially in the summer, because the meat doesn't preserve. You can only preserve the meat. But I'll have to ask my students. I don't have a good answer to that one. But you're right. Much is eaten raw, but certainly they. Oh, I know. Okay, because there's a picture of it in the Chem 13 News. Bannock. Who invented bannock? Was it the Scots or the Inuit? Because bannock is a prime source of fat and carbohydrate in the diet. Yeah, bannock is the prime thing that's cooked, and you'll see a picture of it, the cooking of bannock in the Chem 13 News. So, but it's a good point. A lot of food is eaten raw in the healthiest form. I hope that answers your question, Annie.
I must admit, I was slightly struck by the fact in that picture of it, you showed of a kuluk being lit. But it looked like, I could be completely wrong, but it looked like if there was an air fryer in the background. So, you have a sort of combination of modern technology on the
yes,
and traditional technology on the table.
And the other thing, of course, is that, and I had a quick look before recently, that the different ways that traditionally Inuit lighted the kuluk, and I'd asked Rosalina, and the answer is now you just have an ordinary little cigarette lighter.
Geoff, thank you very much for such a wonderful talk, which combines both chemistry and culture, which is something we often strive at, but so few of us succeed. And to bring in a culture which is known by so little of, of which we normally know so little. I mean, obviously in Canada it's a bit different, but over here in the UK we don't know much about Inuit culture. So to combine all that into a wonderfully lucid talk, we're very, very grateful, Geoff, and thank you for speaking to us all the way from Newfoundland.
Okay,
so thank you.
And by the way, that if you want a PDF of the issue, just get in touch with me and I can send you a PDF of the Chem 13 News issue.
Thank you very much, Geoff. Hello, everybody. Now, it'd be great if you could come to next week's talk by Michelle de Mayo, which is on women in chemistry in the 17th century, another unusual topic. And I hope that many of you, if you're speaking all the way from the Science History Center, Science History Institute in Philadelphia. So I look forward to seeing you next Tuesday as well. In the meantime, goodbye, everybody, and have a lovely afternoon, or in your case, Geoff, a lovely morning.
Thank you.
Bye.